Again, we're going to point to our external BGP neighbor, the customer edge, which in this case is router 6, and then we're going to push this command, which is AS override. And that should be it. So now if we go to router 6 to show IP BGP, as you can see here now that I am learning the 10 network. Also, you can see here that the path has changed too. So it's replaced, it's the 200 with a 100, so it just replaced, and then that's all it does. That's BGP AS override. So now let's see if we can ping all the way through 10.0.0.1. Do a show IP route and take a look and see what's going on here. Again, you got to remember that we're learning via BGP just the 10 network. The reason the ping failed is because the ping is sourcing from this 46.0 network, and the 46.0 network router 5 doesn't know how to get to, so we need to do a source ping. So we'll do a ping 10.0.0.1. We'll just source it from 172.16.0.1 again, because we know that router 5, if we go to router 5, we look in its routing table, do a show IP route. Of course, it doesn't have the directly connected, this directly connected network, the 46 network. You could go under the BGP and do a redistribute connected, under that address family under router 4. We could do a redistribute connected here, and then that, actually let me just show you that real fast. Router BGP 100, address family is IPv4, VRF R6, and if I just do a redistribute connected, what you should see here now is, I do a on router 5, if I do a show IP route, you can see now that I've learned another route via BGP. This is the 46 network, so our ping should work now to 10.0.0.1, because now I have a return path back to the 46 network from router 5's perspective. And as you can see, it works. So also, let's just show you the ping that works from the 10.0.0.1, and then we're going to source that from 172.16.0.0, again, that on router 5 is let's see, show IP. That on router 5 is, router 5 learns about that route via BGP. So I should have connectivity here as well, as I do. So as you can see now, we have just implemented BGP through an MPLS VPN design perspective. Again, the keynotes with BGP is being that if you have two routers that are from the same customer and they're the same AS, and you're learning, you're routing external BGP to them via an MPLS VPN perspective, by default the AS path is not going to allow those routes to be propagated from customer edge to customer edge, because the AS path rule of external BGP is going to deny those routes back into the to that AS for loop prevention reasons. Again, there's two ways around that. As you saw here on router 5, we went on to router 5 and did a if we just do a show run, on router 5 we looked at under BGP configuration on the customer edge, we looked at the allow ASN command, which allowed that routes from the same AS back into the set, into 200 AS 200. So we looked at it on router 5 from the customer edge perspective. How do I get those routes back in? Also on router 4, we looked at it through the from router 4 to router 6. We looked at the premise edge solution. Again, we went under the address family IPv4 VRF R6, which is the specific VRF that's going to router 6. And we did the neighbor command for external BGP. We did neighbor 192.168.46.6, which is router 6, and then we did the AS override command. And then we verified that on router 6 by doing a show IP BGP. And as you can see here now that the AS path was overridden with 100 instead of 200. So router 6 sees those routes as being in AS 100 instead of AS 200, and therefore will allow those routes to come in to to its routing table via external BGP. So I hope you guys have enjoyed this video. Again, MPLS VPN's a lot of fun. Hopefully you guys feel the same way, and I hope you guys will be with me for the next video. Thanks. Bye.